Okay, so I brought in the cabinet here with the speaker. Plug it back in. Here, I can just show you what I was talking about earlier. So, here we are. Oops. Okay, so you can see 4 pins, but only 2 wires, unless you look there. And there's the 2 cut ones. I wonder if you disconnected the wires underneath. Okay, that should do the trick. Okay, I'll plug it in. Hot chassis light is connected. Okay, here we go. My hot chassis light is not on. That's good. Okay, let's see what we get. Can't even get past this point anymore. Doesn't that sound right? Okay, I got my voltmeter here. Just going to check the grid voltages on the caps on these tubes. Slightly negative. -5. Oh, hey, there's a bit of a lesson right there. -0.6. Well, the radio's responding right to the very front end. But there was a couple of things there that make me think. We just got some bad tube contacts. Pretty sticky. Okay. Pretty sticky too. Wow. I don't want to put too much pressure on it with the screwdriver. There we go. Good. be good. Wow. Ugh. What's that sound? That doesn't sound very good. That sounded like this plastic breaking. Ugh. Let's just see what happened there. Just unplug that. Yeah, it all looks fine. I don't like that sound though, boy. Now you're going to take a cap off of a tube that hasn't been removed for a long time. Twisting may not be the best move, because twisting can break the glue that's glued this cap to the glass. So it might be better if you can do it, if you're lucky, like I'm pretty lucky here, to do an upwards pry like that. I'm pretty lucky here though. Even just to get it moving, to sort of break that initial rip. With the twisting motion, a little risky. Yeah, see, this one's coming out more normal. Yeah, something funny about that other. Insist on a genuine Philco tube. 6AF. 6A7. 6A7. Yep. It's a little hard to believe, but on the surface of every metal there is a layer of corrosion. Even this nice shiny metal here, there's a very, very thin layer, super duper thin layer, and that's why this isn't corroding, that thin layer. So even when you look at these shiny materials, this one's not so shiny, but the lug on the top of the tube is a little shinier. There could still be just enough of a layer there to cause problems. You know, and just a little bit of disturbing, you're back in business. So we took this other tube out over here already, and I've taken out the power tube. So that's it. Every tube has been out, except maybe the rectifier tube. I'm not too worried about that. And this guy up here. Okay. So are you ready to try another shot at it here? Let's see if that made any difference. And what are we running for an antenna on this radio? Anyway, just this long chunk of wire. I better stretch it out a little bit. Okay. There we go. Pulling it down. There we go again. No, we're not. Not till we plug this in. Okay. Presto. Well, that appears to have fixed it right up. just taking that long to warm up. That's all. From the restricted voltage. Isn't that a lovely sound? I'm pretty quiet because I have no idea what to do here. Just at the moment. I'm just listening to it make sounds. What's going on over here? My voltmeter is silencing the tube. Let's put on the signal generator and give it a little blast here. Maybe that'll wake it up. Maybe there's something dumb going on with the antenna. Okay, so we don't know which band we're on here necessarily. I guess that's the AM band. Well, I'm not very hopeful for this. And where do I think I am? I think I'm dialed in, it'd be around 1600. I'm going to connect it right to this wire. Oh, look at that. Hey. It works, it's just a piece of crap. How do you like that? I'm sorry, you can't see the frequency there. Let me move that up. Okay, so we're dialed in at about 1600 here. And look where we're coming up over here. Pretty accurate, but pretty weak. Let's try another spot. Around 1000. Well, I don't know what to make of that now. 13. It's just very, very weak. It's just getting weaker and weaker as you go down. It just sounds like really terrible alignment. But could be other things. How about this? How about we give it full voltage? That'd be a good idea. Let's give it the full Monty here. Hasn't made much difference. You hear that tone too? I wonder what that is. And what is that? You know, I don't think that's a plate contact. I don't think that's a short. I think that's the set just falling into oscillation, and then when you back the control up again, it hangs on. The oscillation hangs on. So it gets triggered with a pop, and then yeah. So I don't think that's actually contact. I don't think it makes the difference which band you're on. Then again, it doesn't really matter what I think, does it? A curious, curious thing. Okay. Well, we can try this other band. Why don't we do that? We are on the other band now. Up around 16 megacycles. Boom. Right by it. Up around 20, right at the top. There it is. Pretty darn weak. Weak but working. Well, let's see. We hear a little bit of crashing. Grid voltages seem to be okay. Plate voltages must be there. There's that crashing again. Might end up with just some oscillations screaming away at us here. So the noise was continuing when I had the grid cap off. Oh. But it's before the volume control. That's interesting. Let me see you take a little look at this schematic. Okay, so let's carry on here. Look at the schematic. This is the best way I can do it. Show you a piece of paper. This is a pretty nice schematic, and this is the right schematic. Here, we don't need that blasting away, do we? So, let's see. Volume control. Looks like it's right there. And it looks like the detector right in here. .1 there. I'm trying to spot where the ABC voltage is, if there is an ABC. I think they knew about it by now, by this year. I'm sure they did. So some of these signal grids should be controlled. Not that one. Not in the 6A7. Oh man, I'm just going around in circles here. Round and round, away we go. I see one thing off to the grid of the 6G5. That's the magic eye tube. So this has to be the ABC line here. Down through here. Yep. Right onto the grid, that too. And the voltage is developed over here. Right after the detector. In this network here. So, you know, somewhere back in here. Now, which tube did we pull out? We pulled out this one on the corner here. That's the 6A7. Oh, that's the first tube. Okay, I got these tubes backwards. 6A7's first. I thought I was pulling out the second tube when I pulled the grid cap off. So we can pull the cap off the 6K7 and see if the noise goes away. Which is what we should do. Okay. Things went pretty quiet, didn't they? So what we did is we took the cap off of this tube, the 6K7. So I know things are pretty quiet from there forward in this radio. The noise is coming in here somewhere. What's there? Da 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 da. An IF coil. I say that because it's probably got mica capacitors. No, I don't think so. No, it's just got, you know what? It could just be dirt in the top of these cans. One of these cans. This can, not this can. There you go. By Jovi, I got it. Let's see. We're listening to this one right now. We're listening to everything out here. So it would have to be this one. This is the one that the grid of the 6K7 goes to. It's this one. So reconnect the noisy. And we will of course get no noise. course. What's happening now? Where'd my noise go? Oh! You jumped as much as me? Look at that. Wow. That's a little surprising to me. Don't know what I'm going to find by doing this. I don't normally just sit here and tweak things, but... By Jove, I think we need to align it. Wow, some strange stuff going on here. Yeah, so I think the IF frequency is 456. Yeah, 456. So let's go down to 456. Yeah, it's nowhere near 456. But boy, that part of the radio is hopping, isn't it? So there's really nothing wrong with the core of this radio. It's just getting nothing at all from the front end. I'm probably piercing everybody's ear there. Yeah. I don't want to jump to conclusions and say, wow, let's put it back to 456, because this could have been a technique somebody used to correct the dial on the basis that there's nothing else that can be done to correct the dial. Now usually there's an oscillator trimmer somewhere in here. Let's just see if we can find that guy. Ooh, there's a bunch of them down here. All over the place. This looks like the oscillators through here. Lots of trimmers. This could be them here. Those could really be dirty, couldn't they? Ah, look at that. No signal through these. Wow. Okay. Well, it's that spider again. That little spider guy's done it. See, he was saying all along. Ah, that's spooky, man. I mean, this thing's been dead for 50 years, and moving it around, it looks... it almost looks like it's crawling around on there. Well, this guy needs some attention right here. Yeah. Okay. I think I'm going to stop right there. I'm going a little slow here because it's late at night. That's what's happened. I do this in the morning, I'm a little quicker. This time of night, I'm just a little bit slower. But I think we've kind of zeroed in on where the weaknesses are in this radio. It's in this coil at the front. So I'm going to stare at that schematic for a little while myself and figure out what I should do about trying to bring this back to good condition. I'm sure that there's a number of ways of cleaning this stuff, but the more you do to it, yikes. See you later.